Hello friends, today we are going to see the second lecture of Machine Foundation wherein we are going to solve a numerical. Again, just a quick revision of what is reciprocating machine. It produces higher forces compared to rotary machine uh, and the forces generated are at operating speed as well as twice the operating speed. These are the modes of vibrations in X, Y and Z direction. Correspondingly, we have lateral, vertical and longitudinal modes of vibration. While for rotation in X, Y and Z we have pitching, yawing and rocking mode of vibration. This is machine data from the book authored by K.G. Bhatia, wherein you have compressor weight, motor, rotor and pedestal weight, the weight of operating gear and some speeds given. Just to have a brief revision of what is a compressor and all. Compressor is a mechanical device used to increase the pressure of gas by reducing its volume. Motor uses other forms of energy and converts into the mechanical energy of motion. Rotor is nothing but a moving component of an electromagnetic system in motor, and its motion is due to interaction between windings and magnetic field. The gearbox reduces speed of prime mover by increasing its torque, while pedestal bearing provides support to the rotating shaft. The other data given in the numerical are foundation data, where the mass density of concrete is given as 2.5 ton per meter cube. The length width are given as 5.2 meter, 2.2 meter. Some dimensions of gearbox pedestals are also given. Foundation depth below ground is 3.5 meter, and that of above ground is 1.2. So there is some soil data as well given, that is mass density of soil, Poisson's ratio, bearing capacity, site coefficient of uniform compression, etc. We'll come back to these data when required. This is the primary machine layout in plan, which is again a given data. If you notice, the compressor weight was 220 kilonewton and the compressor here is highlighted by yellow. The weights are given in the form of WM1 to WM11. So all the data given in the machine data are bifurcated in these 11 forms. The compressor of 220 kilonewton is divided into 4 corners of 55 kilonewton each. Similarly, gearbox is having WM7 weight as 8 kilonewton. Pedestal and rotor net weight was of 18 kilonewton, so WM5 and 6 are 9 kilonewton each, and that of motor is 25 kilonewton each on the 4 corners. These are the dimensions given, and X and Y and X and Z axis in the plan are noted. This is a machine and the foundation in elevation, where CG base, that is origin, is pointed at the base. 1, 2 and 3 here are the foundation itself, where one dimension of 1 is 2.2 by 4.5 by 2.2, while that of 2 is 3 by 3.7 by 2.2, and the third is the smallest, that is 0.6 by 0.8 by 0.8. So combining 1, 2 and 3 you will get the total foundation. To start with the design, the weight of machine is given as 220 of compressor, 100 of motor, 14 plus 4 of rotor and pedestal, 8 of gearbox. So net weight of machine is 346 kilonewton. The desired weight of machine as per the mass ratio criteria as discussed in the first lecture should be more than 3 times. So at least 3 into 346, that is 1038 kilonewton is required, that of foundation. The first step is to find out CG of machine, CG of foundation, and the combined CG of machine and foundation together. Why is this required? To check eccentricity if it is less than 5%. The first step is to find out CG of machine. Wi are the weights as discussed of each point. Xi, Yi and Zi are the CGs of individual points. So we start with the very first column of 25 kilonewton weight. Xi, Yi, Zi we require to find out. Now how to find out? Let's go back to the plan again. With respect to this X and Z axis as highlighted, we want to find CG of this particular point WM2. So in X direction the value is 700 or 0.7 positive, while in case of Z it is 100 plus 300 plus 500 plus 1200, giving 2.1 or 2100 in the negative Z direction. Similarly in elevation, we are talking about motors, so in elevation the CG lies at 3500 plus 1000 plus 1000 minus 100, because the machine CG line is 100 mm lower than the rotor center line. So net will become 5.4. So it is 0.7 in X, 5.4 in elevation, and minus 2.1 in Z. So similarly for all the points, this whole table can be obtained. Net weight of the machine comes out to be 100 plus 18 plus 8 plus 220 as 346 kilonewton. We require to find out CG, so the equations are sigma Wi xi upon sigma Wi for X and similarly for Y and Z. So using those equations, what you obtain is X m0 bar as 0, Y bar m0 as 5.41 and Z bar m0 as 0.38. Next, to find out CG of the foundation in form of 1, 2 and 3, we require in the plan X and Z dimensions can be obtained. If we just focus on the elevation, for the first machine, the CG of elevation is at the half distance of 4500. That is 3500 plus 1000 by 2. Similarly for the second block, it is 3500 plus 200, which is noted on the left hand side, by 2, while that for the third one it is 3500 plus 200. The block itself is having height of 800, so it is 800 by 2 in addition to the uh, first two values. So these are the CGs in the elevation. So if you just see to find out CG of foundation, these three are nothing but the dimensions given of block 1, 2 and 3, which are in the given data. So CG from point O are these. So as we just discussed for 1, 2 and 3, the YI was 4500 by 2, which is 2.25. For block 2, it was 3500 plus 200 by 2, which is 1.85. And for third block, it is 3500 plus 200 plus 800 by 2, which gives as 4100 or 4.1 meter. Similarly, X and Z can be obtained. Weight of foundation is nothing but the volume into density. So volume for the first one is 2.2 cross 4.5 cross 2.2 into 2.5 ton per meter cube. So we'll require to multiply this with 9.81 to convert in kilonewton, which gives as 534 kilonewton. Similarly, foundation 2 has 599 kilonewton, third is 9.5 kilonewton. Just as we did for the machine, same has to be followed here. But before that, total weight of foundation comes out to be 1142.5 kilonewton, which is greater than our required uh, mass with the mass ratio criteria of 1038 kilonewton. So we are safe in terms of mass ratio criteria. X bar F0 obtained using equation is 0. Y bar F0 comes out to be 2.066 and Z bar F0 as minus 0.125. Now what we require is to combine these two together, CG of machine and foundation, So it is x bar 0, y bar 0 and z bar 0. This is the equation sigma wm x bar m0 plus wf x bar f0. Now out of which x bar m0, y bar m0 and z bar m0 are that of machine, and similarly these are of the foundations which you have just obtained previously. So using these equations, the net values obtained are 0, 2.84 and minus 0.008 in x, y and z direction respectively. This will be required to check for eccentricity. Eccentricity are always checked in plane dimension, that is in x and z. It is not checked in the vertical direction. So Ex is nothing but x0 bar upon b. Width of the whole foundation is given 2.2 and x bar 0 you just obtained as 0. So it comes out to be 0%. Similarly, Ez is z0 bar upon L. Length given is 5.2. Here z bar 0 will take it as absolute value. So we'll remove minus sign. So it is 0.008 upon 5.2, which gives us 0.15% of eccentricity, which is less than 5%, hence it is okay. So we'll keep up to this much in this lecture. We'll meet in the next lecture for the solved parameters and further calculation of frequencies. Thank you.